Hello, this is Mrs. Keiper, and I will be reading lesson 4.4, the physical property of density. I'm not going to read the ebook. The main lesson goes over all of the information in the ebook, so we're just going to read through the lesson today. Quick, think, which amount would weigh more, a pound of feathers or a pound of rocks? And the answer is, of course, they both weigh the same because they're both a pound, right? Okay. Now think about this question. What if you had two boxes equal in size and you filled one box with feathers and the other with rocks? Would both boxes weigh the same? Duh, no. The box with the feathers would weigh less than the box of rocks because rocks are generally heavier than feathers. You know that feathers weigh less than rocks, but did you know that feathers are less dense than rocks? Because feathers are less dense than rocks, the volume of feathers in a box will weigh much less than the volume of rocks in the same box. In this lesson, you are going to learn about the physical property of density. As you work your way through the lesson, consider this question. Is density an observable or measurable physical property? To understand density, you need to understand mass and volume. Mass is the measurement of how much matter is in an object, and volume is the space that an object takes up. If you know the mass and volume of an object, you can figure out an object's density. There's even a mathematical equation for density. Density equals mass divided by volume. For this lesson, you won't need this mathematical equation, but you will probably see the equation in another science class sometime in the future. Certain materials, such as rocks, bricks, and heavy metals, have a high density. These materials are solids that have tightly packed molecules. Now, atomic theory says that molecules in solids are held closely together and vibrate or move around only slightly, so they're not moving around very much. This means that materials like rocks, bricks, and heavy metals have a lot of mass in the space they occupy, which makes them denser than some other solids. Other materials, such as feathers and woods, have a lower density. Though the feathers and woods are solids, their molecules are not as tightly packed together as rocks, bricks, and heavy metals are. The molecules in feathers and wood are more spread out. This means that materials like feathers and wood have less mass in the space that they occupy, which makes them less dense than some other solids. So consider the image. According to atomic theory, how do the molecules in the brick wall behave? Remember, we talked about brick being a solid, and those molecules in the brick are connected and tightly packed together in the space that they occupy. So those molecules aren't going to be moving very much, and they're going to be kind of held closely together and tightly packed. One way you can think about density is to think about some of the outskirts of Shelton. We have houses that are on 1, 4, 5, or 10 acres of property. One house for 5 or 10 acres. Whereas here up by Olympic Middle School, if you looked in our area, the houses are tightly packed together. Okay, and so here up by Olympic Middle School, there might be 10 houses for 1 acre of land. So we could say that the houses are more densely packed together within the Mountain View area of Shelton than they are on the outskirts of Shelton, where you might have 1 house per 1 acre. So that kind of gives you an example of what density is. All matter has mass and volume, so all matter has density. All 3 states of matter have density. Just like solids, liquids and gases have density. According to atomic theory, the molecules in liquids are less tightly packed than the molecules in solids. In liquids, the molecules move around more freely. They kind of stay close to each other, but they tend to take the shape of the containers they are in. Whereas gases, the molecules are always in motion and bounce around randomly. Gases move around freely. Based on this information, which state of matter do you think has the most density? Solids, liquids, or gases? Jot down your answer in your science notebook if you have it, and we're going to come back to this question in a few minutes. For now, let's focus on the density of liquids as we continue this lesson. Density is a physical property of matter that can be used to identify what it is. Consider different liquids that unfortunately can be found in bodies of water. Mercury is pretty dense. And guys, this is a poisonous metal. Remember I talked about mercury, I saw it once come out of a measuring tool and it bounced on the table like BBs or bouncy balls, but then as it stopped bouncing, it turned into a silver liquid on the table, okay? Mercury is pretty dense and it will sink in water. It's also poisonous to plants and animals, okay? Oil is less dense than the water and it will rise to the top. Think about, maybe you've seen in the news in the past that there have been oil spills in our oceans or in the Puget Sound. Because the oil rises to the top, they can use these little buoys that are filled with, basically they're floating buoys, some sort of a netting or covered material that usually is filled with like sawdust or some floatable material, and they can put those like a gate around the oil in the water, and that will contain the oil and keep it from spreading out into the water. And the reason that works is because oil is less dense than the water and it rises to the top. These liquids, as well as others, contaminate water, and we need to be careful to keep harmful substances out of our water supply. This is why it is so important to follow guidelines when disposing of harmful liquids to protect the plants and animals in our communities. Who can help us make informed choices about the conservation, disposal, and recycling of materials that may hurt our water supply and or environment? Well, both the Center for Disease Control, or CDC, and the Environmental Protection Agency, or EPA, are great resources when disposing of materials that may be hazardous. Use your preferred search engine and type in the potentially hazardous material along with the CDC or EPA to find out the necessary steps to dispose of materials appropriately. The other thing that you can do is we have a landfill site here in Mason County, and if you give them a call, they can help you know how to dispose properly of any harmful substances, okay? So one of the things we see more commonly is we see motor oil from engines going into our storm drains, or possibly because people are changing the oil in their cars or vehicles at home. You know, the oil is coming out of the engine and hitting the ground. One way to dispose of the oil appropriately is to put it in a pan, seal or pan or container, and seal the container. And then you can actually go to our Mason County landfill, and they have something called a hazo hut. And if you tell them you have a hazardous material and tell them what it is, you can actually dispose of that at their hazo hut for free. They don't charge you to dispose of some of those hazardous materials. And so you can always call them and get information on how to dispose of those or recycle some of those materials, and they can help you out with that information as well. I'm going to skip the ebook. It goes over the same information in the rest of our lesson. As you begin exploring the density of liquids, you must also consider another physical property, the property of buoyancy. Simply put, buoyance or buoyance, it's actually pronounced buoyance, is the ability to float or sink. Imagine dropping an ice cube into a glass of water. What will happen to the ice cube? If you're not sure about what will happen, try it for yourself and discover the answer. And as most of you probably already know, if you drop an ice cube in a glass of water, it kind of sinks at first and then it floats right back up to the top. Because the ice cube floats rather than sinks, we say the ice has the property of buoyancy. It can float. But what about the density of the ice cube? You know that ice is a solid. Do you think that solids have more density than liquids? If so, shouldn't the ice cube sink? These questions may make you wonder, how dense is an ice cube? Does its density affect whether it floats or sinks in water? Let's return to a question asked earlier in this lesson. Which state of matter do you think has the most density? Solids, liquids, or gases? Check the answer you jotted down in your science notebook. Do you agree with your original answer, or do you want to revise that answer? Let's explore the answer to this question by considering some important facts about density. If the density of a solid is less than the density of a liquid, the solid will float in the liquid. Even though it is a solid, an ice cube has a lower density than water, so the ice cube will float in water. If the density of a solid is higher than the density of a liquid, then that solid's going to sink when put into the liquid. Think about another solid. Think about a penny. If you throw a penny into a fountain of water to make a wish, will the penny float in the water or will it sink? Well, most of you know that the penny's going to sink because the penny is more dense than the water is. So what about a paper clip? Because it's made of metal, will a paper clip float or sink when you drop it in water? Well, we know if you drop it, usually the paper clip sinks. But remember earlier this year, we made a paper clip float because we put it on a piece of paper towel, put the paper towel, something that floated in the water, in first, and then we put the paper clip in. And the surface tension of the water was able to float the paper clip. So based on the information you have learned in this lesson, which state of matter do you think has the most density? Solids, liquids, or gases? Well, the answer is usually solids have more density than liquids or gases, but there are exceptions. If the density of the solid is less than the density of the liquid it's being put into, the solid will float. Gases can only be denser than liquids and solids if they are under extreme pressure, okay? Gases, for the most part, are always going to be less dense than liquids or solids. Is density an observable or measurable physical property? That's our answer. Density is an observable physical property because the density of a material does not change, no matter how much of the material you have. Remember, a measurable physical property is something where the property will change based on how much of the item you have. So, safety alert. Okay, during the investigation, please wear safety goggles so you won't accidentally splash liquids in your eyes as you are pouring the liquids. Now, boys and girls, I don't want you to do this first experiment at home. I am going to be doing this in class and recording it. But there is a second experiment you can do that is absolutely safe for you to do. And you probably have all of those materials at home. So the first experiment, let me go back to the screen. The first experiment has you looking at the different densities of water, honey, rubbing alcohol, and cooking oil. And some of those items could be unsafe if they splash onto your clothing or into your eyes or your face. So I would rather, for right now, you not try this particular experiment. Again, I will videotape it and put it into our K-12 lesson. But this is an investigation that you can do, okay? It still says to wear safety goggles, but you're really gonna only be using eggs and water. So you will also experiment with the density of salt water to see if you can make an egg float. So you could make an egg float with just salt water, and that would be something that would be more safe for you to try out. And it would also, it also includes items that most people have in their homes. Most people have eggs, most people have water, and most people have salt. And so you could try this experiment with the eggs and getting an egg to float in salt water at home if you would like. And that is the end of our lesson. I will post a copy of Floating an Egg in Water out in our Google Classroom, and this reading will actually be within K-12. Thanks for watching.